Okay, this one, I don't think it gave people problems other than they were confused by the decimals. You just do the problem just as if the decimals were regular numbers. So I'm going to sketch out this problem but not really go through the whole thing. You draw the unit lines. Here's 1. Here's -1. Here is 0.7, -6, 0.6 somewhere here. Make that point. Here's your triangle. So we've done this many times. You get the hypotenuse first. And then this one's cosine. Cosine is adjacent over hypotenuse. Adjacent, this is the angle you're looking for. Adjacent is 0.7 divided by whatever you get for that number here. Easy? So this one should not give you any trouble. I don't think it's that bad. Just remember that the negative inside the square root, you're squaring it, so it becomes positive. A lot of you are drawing the wrong triangles. I don't know, it's like we're reverting back to exam 1. Don't draw the wrong triangles, make sure you get the right triangles. This one, I'm definitely changing this one up, so you're not going to get a nice numerator and a nice denominator like this. You'll actually will have to see things from the calculator. So when you draw this on your calculator, this is what you get, something like this. That's the default window. If you take your trace button across this and try to look for this asymptote, what happens? It jumps, right? So some of you are giving me exact answers for the vertical asymptote, which is impossible because if you look at it on the calculator, there's no way you get the exact answer from that. Even the trace button won't give you that. So guess what I did? If you gave me the exact answer when it says look at your calculator and use your trace button, you didn't use your calculator, so I didn't give you the points for that. So make sure that when you look at this problem that you're actually answering the question. It's not meant to be hard. Some people put just around 0 somewhere. That's fine. You just look at your calculator. Quasi, what?
Where is it?
It's somewhere to the left of 0. Just close by 0 and to the left of 0.
So it's like a 0.0.
Like -0.0 something, it's like to the left, right? And some people just describe it. I'm not looking for an exact answer, but I am looking for you to feed off of this and actually get the calculator business right. Here's something really interesting. If someone got all the calculator parts right, they also got the other part right. They did all the algebra right. But it was very possible for people to get the algebra right and not get the calculator part correct. Which is more useful? No. You're never going to remember that 10 years from now, unless you become a math major because you like math so much, right? Looking at it, you're going to look at a ton of graphs if you stay in biology. So the one that's more useful is looking at a graph. In fact, years ago I asked the biology department, what is it that your students need? And they asked us, don't you guys teach them how to look at graphs? Because they don't seem to be able to look at graphs in biology. That's the more useful skill. So it bothers me that you're not able to look at this. And it's supposed to be easy. Just look at it and say, this is where it happened. I'm going to move this somewhere so it's not by 0. I'm going to move it so that, you know, these are all kind of close by 0. I'm going to move it somewhere. So you actually have to look at your graph and go, oh, it's right here. So that's all I want you to do is look at it and go, oh, somewhere around here. You don't have to be exact. Make sense now? All right, the next question you were asked on this is to look at the picture that you get and make your window so you can see the roots. And a lot of you got that correct, actually. You have to blow up the picture. And what I chose for I went down and said, okay, I know that it's crossing right here. It's crossing the x-axis somewhere here. So I went and said, what do I need my x-min and x-max to be so I get this part blown up? Probably I squeeze my x-min and x-max. Probably x equals 1, x equals 5, somewhere around there. And then I just, since I'm looking at where it crosses the x-axis, I made the y-min and y-max really short. So it's like I'm putting a rectangle right around the region that I want. And what did I end up choosing? I chose x-min is 0, x-max is 4, and y-min and y-max I chose it to be -0.5 plus to +0.5. So I made a little rectangle and blew the picture up, and now I can see it crosses at 2 and 3. And this part here, I'm going to leave this off. I did it on the other part. Most everybody could do the algebra. So again, I don't think it's something, well, maybe you will. Maybe you'll think, oh, that Dr. T that I had back in pre-calc, that was a fun class, and I know how to get my y-intercept. But you know what? Reality is you probably won't remember me, and you probably won't remember that. So. What you do is you just put huge numbers. So you can actually see from the graph itself. This is actually dipping down this way. It's going down. So if you stretch it out, zoom out, you'll see that if you zoom out, this thing goes down this way. So horizontal asymptotes means that it has to flatten out, and it doesn't flatten out anymore. It's going to go down like this, like a check mark.
So you just write none if it doesn't flatten out?
If it doesn't flatten out, the answer is none. But the way you can tell with numbers is to plug in 1,000 into your, and if it ends up being a huge number, then it's not flattening out. Flattening out means that you're going to get the room temperature as time goes out, right? So if you plug in a really huge number and you get out a really huge number, it's not flattening. Does that make sense? And if you plug in a negative huge number and you get a negative huge number out, it's not flattening. Does that make sense?
And that one didn't have the
This one has, yeah, this one's gonna, if you blow it back up and go zoom out, it's gonna go up. I find that acceptable, by the way. I'll change the rubric so that if you say, I zoomed out on my graph and this is what I saw, just draw the picture and say it's not flattening out.
Oh, so you can't just write none?
No, you gotta have some evidence of why you said no. None. Otherwise, you could have just looked at Odie's paper and said none. He said none, so I said none. And that's not evidence, by the way. You can't say Odie said none. That doesn't count. I asked Odie and he said none. Okay, are there any questions on this? I did this one, dirty details, online already too. So if you want to look up, I labeled it, the rational functions, like quiz 6. Yeah, we need to do the attendance sheet. This is your freebie quiz. You want it. Can we have you rip out a piece of paper and put the date on it? And you know what you tell people when they say what happened in pre-calc today? What do you tell them? Nothing.
I have a question.
Sure.
You said we're going to talk to you for like the next exam or for
Yeah,
this
for the next
exam?
exam.
Oh, okay, because I was
Right.
going to say.
No, I didn't. I don't think.
I don't think.